Hello everyone. So in this video, we'll learn about recurrence relation. So as the name suggests, the recurrence relation, it depends on the recursive call, which is the function calling itself. So we can concur a recurrence equation from any recursive call algorithm, which can be further used to calculate the time complexity of that particular algorithm. So when an algorithm contains a recursive call to itself, its running time can be described by this recurrence equation. So a recurrence relation is an equation that defines a sequence based on a rule that gives the next term uh, in the form of the function of the previous term. जैसे हमारा रिकर्सिव कॉल में होता है, हमारी प्रीवियस टर्म जो भी आपके फंक्शन का वेरिएबल है उस पे डिपेंड करती है, एंड दैट प्रीवियस टर्म इज टेकन इनटू द calculation of the next term of that recursive call, right? Let us take an example. Suppose I have a function f1. I'm passing an integer variable here n in that function. Now in any recursive function we have a stopping condition, so I am taking here if n equal to 0, then return the value 0. Then else the recursive part, if n is greater than 0, then I am returning a certain function call, a recursive function call f1 with value n minus 1. So for calculating the recursive equation from this, or the recurrence relation from this, we have to see how much time it will take to complete this algorithm, to execute this algorithm. So if I have the first statement, that will be occurring one time, then second also one time, and this recursive function, recursive call, this will depend on the time taken for this function call with the value n minus 1, right? So if I write the recurrence relation, it will be consisting of two parts. Here, if n equal to 0 and if n is greater than 0. दो कंडीशन है आपकी यहाँ पे n पे, that is containing the stopping part, stopping condition, and the recursive condition. So in this case, the complexity will be, the time taking for this execution will be 1, and unit time, that is, and for this recursive call, it will be taking depending on time of function call n minus 1. So this will be the recurrence relation of this particular algorithm. So let us be more clear about how we can calculate the recurrence relation from another algorithm. So if I take Fibonacci series recursive call, so I'm taking void pip and integer n again in this as the argument. Now here the first condition is n equal to 1, यानी कि आपके फिबोनाची सीरीज में सिर्फ एक ही टर्म है, तो क्या रिटर्न हो जाएगा? सबसे पहली टर्म, दैट इज 0, एंड एल्स second condition is if n equal to 2, if you have to print the second term in the Fibonacci series, then you'll return the value 1, and then the recursive part, else return fib of n minus 1 plus fib of n minus 2, यानी कि previous two terms का sum आप then find out करोगे through this recursive call until it reaches this stopping condition if n equal to 1 and if n equal to 2. So these two stopping conditions are there. So the recurrence relation for this will be consisting of, for the value of n is equal to 1, then n is equal to 2, and n is greater than 2, right? So this will be the recurrence. So in this case, only one statement are there. So it will take a unit time for execution. Here also unit time. And in this recursive call, it will take time depending on the function call, which is with the value n minus 1 plus another function call, which is with the value n minus 2, right? So unit time of previous two and t of n minus 1 plus t of n minus 2, right? So this will be the recurrence relation for this particular algorithm. Now, to further calculate the time complexity from this recurrence relation, we'll study in the next video. There are certain methods through which we can calculate the time complexity. First is the time complexity from recurrence relation. So first is iterative method. Then second is substitution method. Third is recursive tree method. And the fourth one, that is master method. So with the help of these four methods, we can calculate the time complexity from any recurrence relation. So in this video, we learned about how we can calculate recurrence relation or how we can assume a recurrence relation from an algorithm. In the next video, we'll see how we can calculate time complexity from this recurrence relation. So the topic for next video is iterative method. Thank you.